the square root of 275. Now, just looking at 275, a good bet is 25 goes into it because it's a whole bunch of 25s put together. So I'm going to break that apart into 25 times 4, 8, 4, 8, and 11. 11. And then we could break that apart to square root of 25 times square root of 11. Well, square root of 25 is 5. Square root of 11. There isn't a perfect square that goes into 11, so that is fully simplified. The other one is 14 over 42. What you should probably do is reduce 14 over 42 first. So that's going to equal, I know 7 for sure goes into it, so that would be 2 over 6, which can be reduced further to 1 over 3. Well, I can rewrite square root of 1 over 3 as square root of 1 over square root of 3. Well, square root of 1 is just 1, so we have 1 over square root of 3. To get rid of that square root in the denominator, I need to multiply the bottom by square root of 3 and the top by square root of 3, which is then going to equal 1 times square root of 3 is just square root of 3 over 3. So the correct answer would have been A, square root of 3 over 3. Any questions on that? Because I know 2 people got it wrong. I don't know which 2. It just came up as 2 people got it wrong. Okay, then today we're going to get into the Pythagorean theorem. The Pythagorean theorem in a right triangle. So we're not going to use the Pythagorean theorem in every triangle we see. It has to be a right triangle to use the Pythagorean theorem. Says the square of the hypotenuse is equal to the sum of the squares of the legs. Or you might remember it as just a squared plus b squared equals c squared, where a is a leg, b is a leg, and c is a hypotenuse. Just a reminder, this c right here is in fact your hypotenuse. That c right there is your hypotenuse. Easy way to remember it, it is the long side of a triangle, and it's also across from the 90 degrees. So in picture form, you're going to find the one that's across from 90 degrees. That will be your hypotenuse. If I list sizes to you, so if I say a right triangle has sides 3, 4, and 5, you should immediately know that 5 is your hypotenuse because it is the longer length. All right, that's important to know because there are times where I just describe a triangle to you, and you have to figure out which is the hypotenuse. So once again, if I say we have a right triangle 3, 4, and 5, 5 has to be your hypotenuse because it is the longer of the 3 sides. All right, but otherwise it reduces down to a squared plus b squared equals c squared. Right below it, we're going to do what's called a geometric proof. We're not going to do 2 columns. We're just going to show for a fact it's true using geometry and algebra. So here's what that proof is going to look like. All right, we have 2 identical squares, which means both areas have to be the exact same. But we're going to find the area in 2 different ways. On the left-hand side, if you look at those little dots, what I'm going to do is I'm going to connect those little dots with straight lines. All right, now what I have are 2 squares and 2 rectangles. Well, look at that top left. That's a square with sides A. It's got 4 sides with length A. The area of that little square in that top left would then be A times A, or A squared. Remember, the area of a rectangle, a square, is just length times width, which means this bottom right one would be B times B, or B squared. What would the area of this top right rectangle be? Who wants to take a guess? Life?
A times B.
A times B. So this would be A times B, or AB. And this is the exact same size because we have a side that's A, a side that's B, so this is also going to be A times B. Well, the area of the full shape is going to be all those little areas added up. So that would be A squared plus AB plus AB plus B squared, which we can reduce further into A squared plus 2AB plus B squared. Does that make sense, that area equals that if I use those letters? Now we're going to look at the area of the right one. We know they're both the same. So in theory, I could write the exact same thing for this one. I could say that equals A squared plus 2AB plus B squared, but that doesn't get us anywhere. So we're going to find the area in a slightly different way. Instead of connecting those lines straight down, what we're going to do instead is we're going to connect them at an angle like that. And an angle like that. And an angle like that. And an angle like that. Now what I have is a square on the inside. See this big square here? And I also have 1, 2, 3, 4 triangles. Who remembers what the area of a triangle is? Like, you don't get to steal them all. Ethan. 1/2 base times height. So area of a triangle equals 1/2 base times height. That means each of these triangles is 1/2 our base times height. Let's call A our height in this case. So this triangle in the top right, the area is going to be 1/2 A times B. Does everyone understand where I got that from? It's the area of this triangle. Well, this triangle is the exact same size. This triangle is the exact same size. This triangle is the exact same size. So I can put all that inside each of these. 1/2. Ooh, that looks like a terrible 1/2. 1/2 A B. Put that inside this one. 1/2 A B. 1/2. Let's try to keep it inside. See this big shape? We don't have any letters for this, so we're going to create a letter for it. And notice these are all right triangles, so I'm going to go ahead and call this my hypotenuse, and I'm going to call it C. So I'm going to label that as C, which makes this one C, and it makes all of them actually C. So the area of that big square that's in the middle there is going to be C squared. Well, then the area of this entire square is going to be those 4 triangles added to that one big square. So our area is going to equal 4 times the area of our triangle, which is 1/2 A times B, plus that's C squared. Well, we're reducing this just a little bit. 4 times 1/2 is 2 AB plus C squared. Now, I didn't break anything. These are still the exact same squares with sides AB all the way around. This is side AB all the way around. So this area must be the exact same thing as that area. So that means I can set this formula equal to that formula, because they need to be the same size at the end. So we're just going to set that A squared plus 2AB plus B squared equal to the other one, because areas must be equal. Areas of squares must be equal. So we can just set them equal to each other. So we're going to put that a squared plus 2ab plus b squared has to be equal to 2ab plus c squared. And we just have to do one small thing to prove that a squared plus b squared equals c squared. And that is to subtract 2ab from both sides, which you're allowed to do because it's still balanced. That would cancel out, that would cancel out, and I'd be left with a squared plus b squared equals c squared. So it is 100% true that with a right triangle, a squared plus b squared equals c squared. Now there's a ton of proofs that prove this, but we're not going to go through all the different types of proofs. I think this is probably the most straightforward one because it's algebra. We all know how to do areas. We understand that two areas must be the same. So I think the logic follows that most of us kind of understand what happened here, or at least you can see it happen. All right, that being said, now we can use a squared plus b squared equals c squared because we are in geometry, so we should prove stuff first before we can use it. All right, so now that we know it's true, let's go ahead and apply it. It says find x by using the Pythagorean theorem or Pythagorean triples. What I want you to do is cross off that or Pythagorean triples. We used to teach that first, but now we're just going to stick with just the Pythagorean theorem. So that is a squared plus b squared equals c squared. Quick reminder, c squared is always your hypotenuse. So your hypotenuse is 5 in this case. Your legs are 3 and x. So we are just going to do 3 squared plus x squared equals 5 squared. Well, that's just going to be 3 squared is 9 plus x squared. I can't do anything with that yet. Equals 25. Let's get x by itself. So I'm going to subtract 9 from both sides. So we're going to end up with x squared equals 16. I want to know what x equals, not what x squared equals. What do I have to do to get x all by itself and not have that square attached to it? Megan? Do the square root. Yep, so we're going to take the square root of both sides. So I'm going to take the square root of this side, which means I'm going to take the square root of this side. Now, the square root of a square is going to leave me with just x. They're inverses. And then we just have to look at the square root of 16. Now, in algebra, I hope you learned that when you take the square root of both sides, you should do plus or minus. Do you remember that? When you take the square root of both sides, you have plus or minus on the other side. Now, supersede that knowledge, which is the fact that this has to be positive. So we aren't going to look for plus and minus. We're just going to look for the plus version of it. So know that plus and minus still applies. It's just we're pulling the plus one out. All right, so don't forget about that when you get to Algebra 2, that it is supposed to be plus or minus. But since we're in geometry, it's just going to be a positive 4. So we don't have to remember that positive, negative thing. All right, next one is, we're solving for the hypotenuse this time. The hypotenuse is the one from across from the 90-degree angle, so x is my hypotenuse. So we're going to do 6 squared plus 4 squared equals x squared. Well, 6 squared is 36, plus 4 squared, which is 16, is going to equal x squared. Well, this is going to be 52 equals x squared. And I'm going to go ahead and take the square root of both sides. I'm going to flip something really quick. So I'm going to say x equals the square root of 52. However, we spent all that time yesterday talking about reducing square roots, and it's for this one particular fact. On the test, it will say, find x by using the Pythagorean theorem and simplify your result. Is square root of 52 simplified? No, it is not. What perfect square goes into 52? You'll have to check this every single time because right now, if you give this answer on a test, you lose points. Ethan? 4 does go into it. So this is going to equal the square root of 4 times 13. Square root of 4 is 2, so we're going to end up with 2 square root of 13. So that's what we spent all day talking about, reducing the square roots so that you know how to do it, that you don't lose points on the test because you don't know how to reduce it. Questions on reducing? Okay, then let's get through these final two. On our next one, we are solving for a leg because 12 is the hypotenuse. 12 is the hypotenuse. So we're going to have 4 square root of 6, and that whole thing is going to be squared, plus x squared is going to equal 12 squared. Well, just a quick note about squaring something like this. You can think of this as just being 4 squared times square root of 6 squared. You kind of distribute that square to both things. Plus x squared equals 144. Well, 4 squared is 16. I forget, what's square root of 6 squared? What's square root of 6 squared? Sam? 36? Comment it's going to happen a lot. Square root of 6 squared.
Oh, 6.
Just 6, yep. But that's going to happen a ton, I promise you. People are going to go square root of 6 squared is 36. You're so used to seeing 6 times 6 is 36. But that is square root of 6 times square root of 6. So that is just 16 times 6 plus x squared equals 144. All right, 16 times 6 is going to be 60 plus 36, so that's going to be 96. Plus x squared equals 144. 96 subtracted on both sides, you're going to end up with x squared equals 48. Then we're going to take the square root of both sides to give us that x equals the square root of 48. Does 48 look like, square root of 48 look like a simplified? No, it does not. What perfect square goes into 48? Like 16. Ooh, awesome. I thought you were going to say 4. Who was thinking 4? Yep, I would have thought 4 after that, but 16 is a better one because then we cut out that extra step. 16 actually goes into it, so it's always a good idea to just check that extra step, that this is going to equal square root of 16 times 3, which is just going to equal 4 square root of 3. So if you chose 4 right off the bat, you would have had not quite simplified. You have to go one more step. I always make sure anything that's under a square root doesn't have a perfect square that goes into it. 2 doesn't go into it, so it must work. Our last one's interesting just because you have a length being x plus 2. Note that x plus 2 is, in fact, your hypotenuse. So we're going to take our legs and square them. So we're going to have 8 squared plus x squared is going to equal that quantity x plus 2 squared. Well, 8 squared is 64 plus x squared. And remember, x plus 2 squared is actually doing x plus 2 times x plus 2. Why I'm writing that is because the biggest mistakes I see when I do x plus 2 squared is people just say, it's x squared plus 2 squared. It is not. It's x plus 2 times x plus 2, which means I need to distribute. So we're going to have 64 plus x squared is going to equal x. So in my head, this is what I'm doing. I'm doing x times x times 2, and then I'm doing 2 times x, 2 times 2. Well, that's going to give me x squared plus 2x plus another 2x. So that's plus 4x plus 4. Let's get the x's all on one side, or let's move that 4 to the other side. So let's subtract 4 from both sides. And so I'd have 60 plus x squared equals x squared plus 4x. Subtract x squared from both sides. I'm going to have 60 equals 4x. Well, 4x is just going to divide both sides by 4, and we are going to have x equals 15. Questions on any of those? The only real hard part is the algebra. The geometry shouldn't be super hard. You should be able to recognize which is your hypotenuse. And just go, okay, leg squared plus leg squared equals hypotenuse squared. As long as you set that up, you get a huge chunk of your points because this is a geometry class. The remaining points are, can you do that algebra correctly? All right? So make sure you're focusing on being able to reduce square roots, and make sure you do everything carefully and slowly, especially if you have big x squareds in there. All right, questions? Comments? Concerns? All right, cool. The rest of the time is yours to work. Please ask questions if they arise. Remember, the answer key is online to this one. So make sure you check it tonight and you come with correct answers tomorrow.